Hello, hi everyone. Welcome to the Student the Brand. This is our Subha sir. Today we are going to discuss about light refraction. Refraction. So let's discuss. Okay. So before that, just click on like button, share and subscribe. Those are new to the channel. So if you already did, so thank you so much for that. Thank you. Thank you. Okay. So for doing the like, share and subscribe. Okay, so now we are discussing light refraction. Light refraction. Okay, light refraction. Like, share, and subscribe. Subscribe. Thank you. Thank you. Okay, so now light reflection and refraction. Light reflection and refraction. So light refraction topic is left over. So after that we will discuss. So next we will discuss about light, human and colorful word. So next we will discuss about human and colorful word. So if you like the content, if you like the channel, do like, share, and subscribe to Store in the Brand. Like, share, and subscribe. So thank you so much. Now we can see refraction. Refraction is nothing but refraction. Refraction is nothing but, so when light ray is moving from rarer to denser, so this is rarer medium and denser medium. Rarer medium, denser medium. Light ray is moving from rarer to denser at the ends, at the interference between two media. So at this point, the light ray will bend. Okay, so it bends towards a normal line. So I am considering like this. It bends towards a normal line. So the angle between incident ray and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. Okay. So here you can observe this is incident ray, refracted ray. Angle between incident ray and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. Angle of refraction. So the bending of the light ray, interference of the bending of the light ray at the interference of the two media is called refraction of light. So light ray is bending. Okay, so here our light ray, path of the light ray changes. It is towards the principal, towards the normal line. So this is the normal line. This is the normal line. Normal. And this is incident ray. Incident ray. Incident ray. And this one is the refracted ray. Refracted ray. Okay, so the light ray which is deviating through the surface, that is called, okay, this is angle of incidence and angle of refraction. So angle of incidence is greater than the angle of refraction. Angle of incidence is greater than the angle of refraction. So now you can observe like this is a normal line, and so if the light ray is moving from rarer denser to rarer, is moving from denser to rarer here like this. So this is the angle between angle of incidence and angle of refraction. Okay, so angle between incident ray and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. So here you can observe, if the light ray is moving from rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. Okay. So in this case, angle of incidence is greater than the angle of refraction. Here, in this case, angle of refraction is greater than the angle of incidence. Okay. Now, so you can observe here, in this case, so this is a case 2. Case 2. So angle of refraction is greater than the angle of incidence. Angle of refraction is greater than the angle of incidence. Okay. So this is about refraction. The bending of the light at interference of the two media is called refraction of light. Okay. So whenever light ray is entering from rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. Right? Yes. So here angle of incidence is greater than the angle of refraction. Here angle of refraction is greater than the angle of incidence. I hope it is very clear. Now, so we will discuss about next one. So generally if the light ray is moving along the normal line, if the light ray is passing along the normal line, okay, so this is the dotted line, this is the normal. Okay, if the light ray is passing along the normal line like this, so no refraction takes place, no refraction. So even though two mediums refractive index same also, then no refraction will be. So what exactly the refractive index? Okay, if the refractive index of the two media is same, then no refraction takes place. So refractive index is nothing but, so I am taking like this. So this is a normal line. The light rays I am taking here. Okay. So this angle of incidence and angle of refraction, angle of incidence and angle of refraction, angle of incidence and angle of refraction. Okay. So first point, coming to laws of refraction, laws of refraction, laws of refraction, laws of refraction. First point is point number one. So incident ray, refracted ray, normal line lies on the same plane. Incident ray, refracted ray, normal line lies on the same plane. So the ratio of sine of angle of incidence to sine of angle of refraction equal to constant. That is nothing but refractive index. Okay, so here you can observe. The ratio of sine of angle of incidence to sine of angle of refraction equal to constant. That is nothing but. Okay. So now absolute refractive index is there, relative refractive index is there. So now we will discuss about absolute refractive index. Absolute refractive index. Absolute refractive index. Absolute refractive index is nothing but, so the ratio of speed of light in vacuum by speed of light in medium. Absolute refractive index is nothing but the ratio of speed of light in vacuum by speed of light in medium. Coming to relative refractive index is, so the ratio of, so here I am taking this medium 1 and medium 2. Okay, so medium 1 and medium 2. So I am considering this a medium 1 and medium 2. Now N21. So refractive index of medium 2 with respect to 1. So N2 by N1. So we can, with respect to velocity, how we can write. Here you can observe, here from this relation we can write n is inversely proportional to velocity. So then N2 1, if you are taking N2 by N1, that is nothing but V1 by V2. So we can also write N12 equal to N1 by N2 equal to V1 V2 by V1. V2 by V1, inversely proportional. Inversely proportional. So here you can see that N equal to C by V. N is inversely proportional to velocity. N2 1 equal to N2 by N1, that is equal to V1 by V2. N12 equal to N1 by N2 equal to V2 by V1. Inversely proportional we are taking. Okay. So this is about loss of refraction. This is about loss of refraction. This is about absolute refractive index. Absolute refractive index. I hope it is very clear. Now, so this is a glass slab. So this is the incident ray, and I am taking this a normal line. Normal line. So the light ray is passing like this. Okay, so it is emerging out. Okay, so now you can observe this is the incident ray, and this one is the refracted ray. This is the refracted ray. And the emergent ray, this is emergent ray. Okay. Once again, so incident ray, refracted ray, emergent ray. The angle between incident ray and normal line is called so the angle between incident ray and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. Angle of emergence. Okay. So now you can observe here. Now you can observe. So incident ray, refracted ray, normal emergent ray. Incident ray, refracted ray, emergent ray. Angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. When light ray is moving, from rarer to denser, the light ray is moving from rarer to denser, okay. So rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. Okay. So if it is moving from rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. Okay. So the distance between emergent ray and initial direction of the incident ray. Emergent ray and initial direction of the incident ray is called lateral shift. Lateral shift. So it is called lateral shift. So lateral shift. Coming to vertical shift. So I am taking the beaker here. I am taking the beaker. So beaker I am considering like this. This is a beaker. So I place the coin at the bottom of the beaker. So I am standing here. The person is standing here. Okay. So you can't able to see the coin from here. So you can't able to see the coin. Okay. So after pouring water, you can see. So the coin position will rises up. The coin position will rises up. So the coin position it will appears here. Okay. So here you can observe here. So this is the position of the coin and this actual position of the coin. Actual position of the coin, and this one is the apparent position of the coin. Apparent position. Okay. So here you can observe. So when you place the coin is at the bottom of the beaker. So when you are standing here, you can't able to see the coin. After pouring water, the coin position rises up. The coin position rises up. So this is the apparent position of the coin and actual position of the coin. And the distance between actual position to apparent position is called, the distance between actual position to apparent position of the coin is called vertical shift. So this is called vertical shift. Vertical shift. Vertical shift. I hope it is very clear. Okay, so once again you can observe. So here is the lateral shift. The distance between emergent ray and initial direction of the incident ray is called lateral shift. And here the distance between actual position to apparent position of the coin is called vertical shift. Okay. So now you can observe incident ray, refracted ray, normal emergent ray, incident ray, refracted ray, emergent ray. So the angle between incident ray and normal line is called angle of incidence. Angle between refracted and normal is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. And here you can observe the distance between emergent ray and initial direction of the incident ray is called lateral shift. And coming to vertical shift, the distance between actual position to apparent position of the coin is called vertical shift. I hope it is very clear. Okay. So now you can observe. So a pencil is placed inside of the water. Okay. So water beaker. So it appears to be bent at the interference of the two media. So it appears to be bent. Okay. So here you can observe this the beaker like this. Okay, so water is there here. So pencil is placed over here. Okay, it appears to be bent. At the interference of the two media. So due to refraction of light. Okay. So and even if you place lemon inside of the water, so even lemon placed inside of the water, it appears to be bulged. So normally if you observe in front of the shops, okay, so lemon is placed inside of the, okay, so glass, okay, water placed in that inside of it, it appears bigger. So due to refraction of light. Okay, so here also same thing. You can observe all these points. So glass slab, incident ray, refracted ray, emergent ray. Angle between incident ray and normal line is called angle of incidence. Yeah, angle between refracted and normal line is called angle of refraction. And and the angle between emergent ray and normal line is called angle of emergence. Okay, so these all points we can say. So this is about coin is placed in the beaker. It appears okay. So initially it is not visible. Later, after pouring water, the position of the coin rises up. So the distance between actual position, this is actual position. So coin is still, it is at bottom of the beaker. So after pouring water, the position of the coin rises up. So that is distance is called vertical shift. And coming to the pencil is placed, okay, in the beaker. So at this point, at the interference between actually the pencil is look like this, but it appears here. Okay, so actual position of the pencil is straight only, but when you place inside of the water, it appears to be bent. Okay, so due to refraction of light. So this is about glass lab and three examples. Now we will discuss about lens. Now, so we'll discuss about lenses. So spherical lenses, there are two types of lenses, convex lens and concave lens. Convex lens and concave lens. Okay. So so please do like, share and subscribe and share to your friends as much as possible and ask your friends to join to the class. Okay, so share in our class groups and friends groups. So share to your friends, ask your friends to join to the class as much as possible. So because live class is going on. So frequently, continuously I'm taking classes related to CBSE grade 10 physics and the notes also available. So for four chapters, light reflection and refraction, human and colorful world. So electricity and magnetic effects of electric current. Okay, so all those chapters are there. Okay, so notes is available. So it will be very less cost only. So for a less cost only, I'm providing the notes. Okay, so if you want notes, you can send a text message to the number. I will give the number to the WhatsApp number. You can send hi, and so actually the cost of the handwritten notes is 100 rupees only. You can send to that number. So I want notes like that. So I'll share your note. I'll share the notes. Okay. So 9849812804. Okay, so you can contact to this number 9849812804. Okay, so to this number you can send. So for class notes, for class notes, for for notes, physics. So CBSE grade 10. Okay, na? So for notes you can. So cost of the notes is 100 rupees. So those who want, you can take it. Okay. So notes physics 100 rupees only. you can contact that number. I'll provide those who want notes, class notes. So now we are discussing about spherical lenses. Lens. Okay, lens. We are going to discuss about lens. Okay, there are two types of lens. So convex lens and concave lens. So this is a convex lens. Convex lens. So optic center. So optic center F1, 2F1, F2, 2F2. Okay, F1, F1, 2F1, F2, 2F2. And coming to concave lens. Concave lens. So optic center F1, 2F1, F2, 2F2. Okay. So you can observe here. So this is concave lens and this one is a convex lens. Convex lens and concave lens. Concave lens. Convex lens and concave lens. Now we will discuss about ray rules of convex lens and concave lens. Okay, so convex lens, convex lens, convex lens. So convex lens I am taking. So optic center F1, 2F1, F2, 2F2. So light ray is coming from infinity after refraction. After refraction, it passes through focus. Light ray is coming through. Okay, so light ray is passing through focus. So first one coming to second one. Optic center F1 to F1, F2 to F2. Okay. So here light ray is coming from infinity after refraction passes through focus. So here light ray is passing through focus like this after refraction. So it is parallel, it become parallel to the principal axis and moves towards infinity. Okay. So next one, third one. So optic center F1 to F1, F2 to F2. So light ray is passing through optic center. Okay. So light ray is passing through optic center. So no deviation takes place. It moves. Okay. So I hope it is very clear. Once again, you can observe light ray is coming from infinity after refraction passes through focus. So focus, light ray is passing through focus after refraction moves towards infinity. Light ray is passing through optic center. Okay, so without any deviation, so it moves. Okay. Next. So next I'll explain about concave lens image formations, concave lens. Okay, so I'm taking like this. So optic center F1 to F1, F2 to F2. So light ray is coming from infinity after refraction. So light ray is coming from infinity after refraction. So it passes through focus. So first one, coming to the second one. Optic center F1 to F1, F2 to F2. So light ray is passing through optic center. So light ray is passing through optic center like this. So after refraction, it become parallel to the principal axis and moves towards infinity. And coming to third one you can observe optic center F1 to F1, F2 to F2. Okay. So light ray is passing through optic center. So like this. Light ray is passing through optic center. No deviation takes place. Okay. Once again, you can observe here concave lens. Light ray is coming from infinity after refraction. So it will move away from the principal axis. And here you can see light ray is passing through focus after refraction become parallel to the principal axis and moves towards infinity. And here, so light ray is passing through optic center, no deviation takes place. Okay. So this is about concave lens and convex lens completed. Now we will discuss about image formations. Image formations of convex lens and concave lens will discuss. Image formations of concave lens and convex lens. Convex lens. Okay, so convex lens will discuss. Optic center F1, 2F1, F2, 2F2. Okay, so now you can observe. So light rays, so one light ray I am taking like this, another light ray I am taking like this. So after refraction, the light rays will meet at one point. Object is at infinity, image is forming at F2. Nature of the image is real and inverted. Okay, so nature of the image is real and inverted, and size of the image is, what size of the image? Highly diminished or highly enlarged? Highly diminished or highly enlarged? Highly diminished. Highly diminished. Point number 1. Coming to point number 2. So I am taking like this. So optic center F1, 2F1, F2, 2F2. Okay. Object is placed beyond center of curvature. So I am taking here like this. So one light ray I am taking like this. Okay, one light ray I am taking like this. After refraction. Okay, so here you can observe after refraction it passes through focus. And another light ray I am taking like this, passes through optic center. So here you can observe. So object is placed beyond center curvature. Image is formed between F2 and 2F2. Okay, object is placed between beyond 2F1. Beyond 2F1. Image is found between F2 and 2F2. So nature of the image is real and inverted. Nature of the image is real and inverted, and size of the image is diminished. 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 Compared to the object, image size is decreased. Okay. So I hope it is very clear. So this is about so convex lens. So object is at infinity. Image is formed at F2. So nature of the image is real and inverted, and size of the image is highly diminished. And here object is placed beyond to F1. Object is placed beyond to F1. Image is formed between F2 and 2F2. Nature of the image is real and inverted, and size of the image is diminished. Okay. So now coming to the third one. So I am taking third one like this. Optic center F1, 2F1, F2, 2F2. Okay. Object is placed at 2F1. Object is placed at 2F1. Okay, object is placed at 2F1. Image will form at 2F2. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So one light ray I am taking like this. So after that it passes through focus. So another light ray is passing through optic center. So Those two light rays will meet at 2f2. Okay, so here I am taking like this. So this is a 2f2. Okay, object is placed at 2f1, image is formed at 2f2. Object is placed at 2f1, image is formed at 2f2. Nature of the image is real and inverted, and size of the image is same size. Okay, same size of the image will form, same size. So, and coming to the fourth one, okay. Optic center F1, 2F1, F2, 2F2. Object is placed between F1 and 2F1, like here. Object is placed between F1 and 2F1. So how many light rays are required to form the image of the object? How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object, right? So I am taking like this. Well, after refraction passes through focus, another light ray I am taking like this. So it passes through optic center and the image will form here. So the image will be here. The image will form beyond center of curvature. Object is placed between 2f1 and f1. Okay, image will form beyond 2f2. So object is placed between 2f1 and f1. Image is forming beyond 2f2. Beyond 2f2. Nature of the image is real and inverted. Real and inverted. Real and inverted. Size of the image is enlarged. Enlarged. So, and coming to next fifth one and sixth one. So, very important. Once again, I will explain this. So, these diagrams, once again, you can see object is placed at infinity. Image is formed at f2. So, nature of the image is real and inverted and size of the image is highly diminished. And in this case, okay, so object is placed beyond 2f2. Image is found between f2 and 2f2. Nature of the image is real and inverted and size of the image is diminished. And here object is placed at 2f1. Image is formed at 2f2. Nature of the image is real and inverted and size of the image is same size. And here object is placed between 2f1 and f1. Image is formed beyond 2f2. Nature of the image is real and inverted and size of the image is enlarge. Compared to the object, image size is increased. Compared to the object, image size is increased. Compared to the object, image size is increased. So next one. So next two cases are there. Object is placed at F1 and object is placed between F1 and O. Okay, so this we will discuss now. So here you can observe object is placed at F1. Object is placed at F1. How many light rays are required to form the image of the object? How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Minimum, 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 minimum. Minimum 2 light rays are required to. So how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So I am taking here one light ray I am taking like this. After that passes through focus. So another light ray I am taking through optic center. So those light rays will meet at infinity. Infinity, 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 infinity. Object is placed at F1. Image is formed at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Highly enlarged. Okay. Highly enlarged. Now, 6-1 we will discuss. So, 6-1 is very, very important. 6-1. 6-1 is very, 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 very. So 6-1 is very, very important, very, very important, very, 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 very important, very, 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 very important, 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 very important, 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 very important. Object is placed. Object is placed between F1 and O. So one light I am taking like this. After that it passes through focus. Another light I am taking, it passes through optic center. Okay. So if you are extending this light rays. Object is placed between F1 and O. So image will form. Image will form same side of the object. 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 Nature of the image is virtual erect. So nature of the image is virtual erect and enlarged. Compared to the object, image size is increased. Compared to the object, image size is increased. Okay, so I hope it is very clear. Now, concave lens, we'll discuss concave lens. Concave lens. Concave lens. Concave lens. So concave lens, only two cases are there. So I am taking here optic center F1, 2F1, F2, 2F2. So object is placed at infinity. Object is placed at infinity. So how many light rays I am taking? 2 light rays. So here I am taking like this. Okay, so light rays, if you are extending, those light rays are meeting at F1. Object is placed at infinity. So image is formed at F1. Nature of the image is virtual erect and highly diminished. Virtual erect and highly diminished. Okay. So here, so object is placed at infinity, image is formed at F1. So nature of the image is virtual erect and highly diminished. And coming to the next one. Optic center F1, 2F1, F2 to F2. Okay, object is placed anywhere between optic center and infinity. So one light ray I am taking like this, it will be diverging. Another light ray is passing through optic center. So if you are taking here, the image will form here. Okay. So object is placed between optic center and infinity. Object is placed between optic center and infinity. Optic center and infinity. Image is forming between F1 and O. So F1 and O. So nature of the image is virtual erect. Nature of the image is virtual and erect, and size of the image is diminished. So size of the image is diminished. Okay. So this is about concave lens. And coming to the power of lens, the reciprocal of focal length is called power of lens. P equal to 1 by F. The degree of converging or diverging of lens such is known as power of lens. Okay. So P you are taking P equal to 1 by F. 1 by F I am taking. Next. So for convex lens, power is positive. For concave lens, power is negative. For convex lens, power is positive. For concave lens, power is negative. Okay. Next, sign conventions will follow the same thing, and SI unit of power of lens is diopter. SI unit of power of lens is diopter. P equal to 1 by F. So thank you so much for joining and attending and listening my class. Do like, share, and subscribe to Student D brand. So thank you so much for our attendance, for our attending the class. So this is our Siva sir from Student D brand. Do like, share, and subscribe to Student D brand. Share to your friends. Ask your friends to join to the class. Thank you so much. We'll see you in the next class. Thank you.